Hello everyone, my name is Kadek Arya Darma Pradnyana with 3 last digit student ID 063. Today I will present about OWASP Top 10 about cryptographic failures. This course is computer security course. Okay, next. The topic is about cryptographic failures. Cryptographic failures refers to weakness in how system protect sensitive data using cryptography. These failures often occurs due to missing encryption, weak algorithms, and incorrect implementation. As a result, attackers can easily access confidential information. Let's imagine if you diving enough in the internet, you can easily supporting a website that's storing password in plain text. Imagine your password stored in a website, but then you realize it's stored exactly as you type it. No protection, no encryption, no hashing. What will happen if the database gets leaked? That would be big disaster. I can imagine about what would happen in my data if all get leaked in a silly website. What is sensitive data? If you didn't know what the sensitive data are, is sensitive data is any information that must be protected from unauthorized access. For examples, account password, credit card numbers, personal identity, for example, ID numbers and address, etc., health records, private communication, bank account PIN, and restricted files. Not all data requires encryption, but sensitive data must be always protected from any unauthorized access like the cracker, the hackers, and the cyber criminals. What is cryptography? Cryptography is the practice of securing data by implementing mathematical formulas, transforming raw data into a protected format. There are two main types. First is encryption, converts readable data, plain text, into unreadable form. Ciphertext can be reversed using a key. For number two is hashing, converts data into a fixed length string, cannot be reversed, one-way function, commonly used for storing password. So cryptography is using mathematical like modulo that cannot be reversed, prime numbers, and combining them into uncorrected encryption. There are causes of cryptographic failures. First is storing data in plain text. Some systems store password directly without protection. Example, username, admin, and password 1, 2, 3, 4, 5, and 6. If a database leak occurs, attackers can immediately access all accounts. So avoid storing password in plain text. Unfortunately, if hackers gaining access in a system, that username and password is easily accessed to your account. They are very cruel. Number two is using weak hashing algorithms. Example of weak algorithms is MD5 and SHA1. These are considered insecure because they are fast and predictable, usually correct using brute force or rainbow tables. Number three is lack of encryption in data transmission. If a website does not use HTTPS, data is transmitted in a plain text. Attackers can intercept it using man-in-the-middle attacks. There are software called OWASP or packet sniffer. It can easily intercepting a communication between a person and a database. So the attackers can easily sniffing your packets. So avoid use HTTPS in a public network. Number four is improper cryptographic implementation. There are common mistakes. First is storing encryption keys in a source code, not using salt password in hashing, not using salt in password hashing, using outdated cryptographic libraries. Here's the real world impact. Cryptographic failures can lead to data breaches, identity theft, financial loss, and loss of user trust. In many real world cases, breaches happen not because attackers are highly skilled, but because systems use weak or outdated security practices. If you're curious how attackers exploit this weakness, attackers may use brute force attack, guessing the password repeatedly and quickly. Dictionary attacks using common password list. Rainbow tables, pre-computer hash cracking. Packet sniffing, capturing unencrypted data. Here's prevention you can do and best practices to avoid these cryptographic failures. For number one is use strong hashing algorithms. Recommended is using Bcrypt, Argon2, and PBKDF2. Number two is use salting. Add random data to password before hashing. So the attackers didn't know what the real password is because the real password is added by some string that distinguish the real password. Menyamarkan password asli karena sudah diberi string random. Jadi lebih sulit ditebak oleh hackers itu. Prevents identical password from having in the same hash. Number three is enforce HTTPS, TLS. Encrypt all data during transmission, protects against interception. And number four is proper key management. Store keys securely, not in code. Use default or environment variables. Number five, use trusted libraries. Avoid creating your own cryptographic algorithms. Just use the popular one, the popular and highly trusted mathematical cryptography. Use well-tested and updated libraries. Don't use outdated library because the technology has developing so far. Outdated program might be easily corrected. Number six, minimize data exposure. Only store necessary data. Avoid storing sensitive data if not required. And here's the conclusion. Cryptographic failures occurs not because cryptography is ineffective, because it is misused or improperly implemented. Key takeaways: sensitive data must be always be protected. Avoid outdated algorithm like MD5, like I said before, MD5, SHA1. Use modern security practice and tools. Here's a quote. It says strong security is not just about using cryptography, but using it correctly. Security is only as strong as its weakest implementation, and in many cases, that weakness is cryptography. Okay. Thank you for your attention.